When I first thought of the Earth as a self-regulating system, it was in 1965, over 40 years ago, and it slowly evolved in my mind over the next couple of years or so. And I used to live in those days in Wiltshire, in the village of Biogeochemistry, and a near neighbour of mine was the famous novelist William Golding, who subsequently got a Nobel Prize for his writing. And he was a close friend of mine, and we used to often to walk to the village shop to get things or post our letters. It was also the post office. And he would quiz me about what I was doing in science, because he was very interested in science, although he was a literary man. And I told him about this idea of a self-regulating Earth, and he said, well, you better give it a proper name. It's too big a theory just to be some scientific acronym or something like that. So I suggest you call it Gaia. Since I introduced the concept of Gaia, it's gradually become mainstream science. They never talk about it as Gaia because the biologists scorned it so fiercely in the early days that most scientists are scared of using the word. So they talk about Earth system science, but it's the same thing. And we now realise that the Earth does regulate itself, and we know quite a bit about all the various systems. You see, it's a good theory. It's made no less than 10 predictions that have come true. And that's good going for any theory. For example, we now know through Gaia Theory that the clouds over the great ocean areas of the Earth are produced by organisms living in the surface, the algae. They produce gases that go up into the air, oxidize, and produce the nuclei around which cloud droplets form and reflect sunlight back to space. The Earth would be perhaps 10 degrees hotter were it not for the existence of those clouds and the organisms that produce them. We also know that the removal of carbon dioxide from the air would not take place at anything like as fast as it does were it not for the organisms present in the soil and on the rocks and everywhere around the Earth and in the ocean as well. And those twin processes, reflection of sunlight and pumping down of carbon dioxide, are what keeps the Earth regulated. If there were no life on Earth, and this is such an easy calculation, you can practically do it on the back of an envelope, you would find that the Earth's temperature would be well over 60 degrees Celsius throughout. I have no personal doubts about the validity of global warming. There are not only are there specific events, odd events, that have happened so rarely in the past that they're extraordinary, but there's a concatenation of them, one after another happening, that the man in the street notices. Ask almost anybody if they think the climate's changed in the last couple of decades, and they'll all say yes and give you lots of examples of why. I mean, just think of here where I'm living. People are talking about growing olives in Devonshire. Would you believe it? Wine is grown all over the place now. There's even vintage British wines. The whole thing is changing, and changing in a way that the man in the street notices. However, to add to that, we're nearly all urban now, and we live in air-conditioned houses and cars and so on. And we don't see anything as much of the environment as our ancestors did. Well, and because of that, we've lost touch with the natural world and are unaware of the changes that happen in it. Global warming is much more than just a real effect. It's something deadly that'll threaten nearly all of us who are now alive on the Earth by the end of this century. The climate right now, if we'd never developed as an intelligent species, would be probably moving slowly back towards the next glaciation. There's some debate about that. Some think the present interglacial would have gone on a bit longer this time, perhaps as long as 50,000 years. But sooner or later we'd have gone back into an ice age again. Now we will not. By putting all that much carbon in the atmosphere, we've irreversibly changed the Earth so that it won't go back to another ice age, not at least for another 200,000 years. The climate change we're seeing now is closely similar to a geological event that occurred 55 million years ago at the beginning of the period the geologists refer to as the Eocene. What happened then was, we're not quite certain how, but something like 2 million tons of carbon dioxide came into the Earth's atmosphere over a period of about 10,000 years. And I think the most likely cause was a volcanic sill, lava underground from a volcano coming up beneath a petroleum deposit which was in what is now the Norwegian Sea. And this vaporized practically the whole of the deposit and put this huge quantity of carbon into our atmosphere. Well, when you ask about 20 to 30 years ahead, I can speak not just from my own view, but from the expressed opinions of senior climatologists who have represented their thoughts in the Intergovernmental Panel on Climate Change's Great Reports. The most recent was in 2001, but one is due next year, the update, and I've seen it. And what it says is this, quite simply, and it's very stark, that by something like 2040 to 2050, the European excessive summer of 2003, when over 20,000 people died of overheating, will be the norm. Every year will be as hot as that, nearly. Now, the consequences for people might be dealt with. They may go away for the summer to cooler places, or they can turn up the air conditioning. But for the plants and the ecosystems, there's no such relief. And the probability is that European agriculture will cease to produce food by then. It'll become a desert and scrub region naturally. That's not very far ahead. So where do the European people get their food? Because the rest of the world will not be exempt. Asia, America will all be suffering the same consequences, as will Africa and the other nations of the southern hemisphere. We will be entering a world where supplies of food becomes more and more scarce, and there will be mass migrations. Anyone with an imagination can see the awful human consequences of that, and we're talking about something which is only about 30 years ahead. If we follow the 55 million years ago precedent, temperature rise will now be levelling off as the Earth system, what I call Gaia, takes control. Just like when one of us gets a fever, our temperature doesn't go up until we become roast meat. It levels off at a higher level and after a while sinks back again. Same's true of the Earth. Many times in the past, when there have been catastrophic events, that it's had a fever and its temperature has gone up, but never to totally destructive levels. We wouldn't be talking about it if it had. And so that's what I think will happen. It'll level off towards the end of the century at about 8 degrees warmer than it is now. That's a huge change when it's looked at on a global basis, and it takes us to a region that humans have never experienced before, a state that it will be likely to last at least 100,000 years. I happen to think that there are too many people on the planet now. I think Malthus was right. You see, he wrote his famous treatise in 1800. At that time, there were only 1 billion people on Earth. And if his advice had been followed at that time, and all the great green ideas of sustainable development and renewable energy and so on had been applied then in 1800, we might have escaped the mess we're in now. Perhaps not all of it, but a great part of it. But we didn't. We went on increasing our numbers. I think that now 6 billion plus on Earth is quite unsustainable in any sense. Our giant mistake was combustion, learning to burn things. At first it was harmless just for cooking, but we never stop at that level. We start doing it on a grand scale, like burning down whole forests, because you get cooked meat a lot cheaper that way. It's much less effort. And that was our mistake. And we've been making the mistake for a long time, and we're only just beginning to discover how serious a mistake it was. Remember, it's not just modern man that's damaging the planet. The first people to move to Australia during one of the previous ice ages, a long time ago, managed to destroy almost the whole ecosystem of that continent with just quite simple tools, fire drive hunting and tricks of that kind. So we're a pretty unpleasant species in many respects, and always have been. Modern man is just more efficient at doing bad things. I think we are, as a consequence of global warming, going to have a major mass extinction of life on Earth. And if you include numbers, it'll be an extinction of humans too. I don't see more than, at the very best, 20% of us surviving through, maybe a lot less than that. And it's a very interesting question, because the event 55 million years ago was not a mass extinction. There was very little extinction of life, even though very much the same things happened. And the difference was that pollution of the atmosphere naturally took place over 10,000 years, and organisms had a chance to migrate to the cooler polar regions, where they survived throughout the 200,000 years of heat, and then they migrated back. We're doing it so rapidly that organisms don't have time to get up to those regions. They're not doing badly. It won't be a total extinction. It's quite surprising that the doubters of global warming will still comment on the fact, isn't it remarkable, I saw in my garden a hummingbird hawk moth last week. It must have flown up from Africa. Why? It's flown up because it's so much warmer here now. It's a habitat. I'm not a nuclear fanatic. I don't think it's the right answer to make the whole world nuclear. That's going too far. I think we have to use the energy we have available that is efficient and will give us what we need with the minimum damage to the planet. And for densely populated countries like Japan, Britain, Germany, and many other European countries, nuclear energy is almost ideal. It's got a minimal footprint on the Earth and yet produces huge quantities of electricity at a very reasonable price that everyone can afford, and will keep cities going. And never forget, we're urban people, and a modern city like London or New York would convert to a camp like one of those in Darfur in 1 week if electricity was switched right off everywhere. I think that nuclear has got to evolve in the way all energy systems evolve, and I'm very pleased to see that the latest nuclear plants, and one is now being built in South Africa, are small-scale plants that just provide enough electricity for a small region. They're the so-called pebble bed reactors. They're quite small, quite safe, and very suitable. And that kind of evolution always goes on in engineering. We should remember that the very first nuclear reactors in the world that supplied energy were built in this country, Britain, in the 1950s, in 3.5 years, just from drawings. That's all it took, and one or two of them are still working. Personally, and I'm supported in this by no less a dignitary than Hans Blix, who said about 2 years ago, "What's all this fuss about nuclear waste? There's hardly any of it, is there?" And that is the point. Last Christmas, my wife and I were invited to Sellafield, which is the British depository of all nuclear waste practically so far. And we walked around at the plant. It's quite a pleasant plant to walk around. And found that the radiation level, with a handheld monitor of mine, not one that had been supplied, was about the same as it is here where we're sitting in this room. In other words, completely safe. Around the building, which was not very large, where 40 years of all of Britain's nuclear waste, civil and military, was stored, the radiation level rose to just above that in the streets of St Ives, a town about 60 miles from here, that happens to be in a rather uranium-rich bit of soil. Still absolutely harmless. Now, all of that waste in that building, and it wasn't a very large building, is in the form of blocks of glass that have been fused. What is the problem, I ask? Now, when you compare that with the carbon dioxide waste, each year we produce, if you froze the carbon dioxide or fixed it, as they want to do, into something like magnesium carbonate, it would make a mountain 1 mile high and 12 miles in circumference every year. Now, that is truly deadly and will kill nearly all of us if we go on doing it. So what on earth do you want to fuss about nuclear waste for? If you go to France and much of Europe, you are riding in trains that are powered by nuclear electricity. Everywhere. French have been very sensible. They run almost everything on nuclear. The very Greens who scream about the dangers of nuclear have homes, second homes in France. They're mostly wealthy people. They don't seem to notice it there. Such is the perversity of people. No, but you couldn't have a nuclear-powered car with a nuclear motor in it. That's ridiculous. But what you can do is run it on batteries, and it won't be long before they're all running on batteries, and they can be charged from nuclear electricity. So that's the way it would go. Planes will take longer. I think that the so-called alternative energy schemes like wind, solar power, and so on are pretty inefficient and impractical and no solution to our problems at the moment. And I think they're dreamt up by urban people who want to do something natural. They don't like anything industrial and feel that they're doing good. But they're not. That's not a way to run a country or a world. There are some what you might call natural power sources like hydroelectricity that are excellent. Why not use them? Norway largely runs on them. And if you've got hydroelectricity, use it. But the sad thing is we've used about all we can. There isn't any left to spare. One day maybe we can get energy from tidal sources. And I do wish the British government had had the sense to build the so-called Severn barrage. That's a power scheme across the estuary of the River Severn in western Britain that would provide the output of 4 major nuclear power stations. But there were too many arguments about doing it, and I'm afraid the Greens were the main objectors. They thought it would upset a wildfowl habitat somewhere or other, so it wasn't done. There is a nuclear power station not too far from here at a place called Hinkley Point in Somerset. I think our benighted government, over-influenced by Greens, may well let it shut down in, I think, even as soon as next year. If they do, it would require 3,200 giant turbines to replace it, and they would only work when the wind blew, which it doesn't very often. Hinkley Point has provided most of Devon, Cornwall and Somerset with electricity for the best part of 30 years without any problems whatsoever, so why close it? As a scientist, and one who when I was young read science fiction, that question, are we likely to be able to do anything about it by engineering or science, really fascinates me. And there are a lot of proposals up at the moment. Some colleagues of mine in NASA at Lawrence Livermore Laboratory have what seems a very reasonable scheme for putting up sunshades in space that would be at the gravity neutral point between the Earth and the Sun, so that it wouldn't take much effort to hold it there. And it would be a carbon fibre diaphragm spun out, I've forgotten the diameter, but quite large, 10 miles at least. And it's not impractical. They say it would cost less than the space station, but it would disperse about 2% of sunlight coming in and relieve us of global heating. Now, that's one proposal. It would take a lot of time and a lot of politics to get it working, but it might happen. Another, much more practical one, is that we could mimic the great volcanoes. When Pinatubo went off in the 90s, it set back global warming for 5 years, stopped it happening, just because of the aerosol of tiny particles of sulfuric acid in the stratosphere reflected sunlight back to space. Now, Russian scientist Bodaiko suggested we do that as long ago as the 1970s. To alleviate global warming, but it wasn't taken up then. But it is beginning to get taken up now as a serious proposition. It would be quite easy to do. I would like to see it done by just getting the main airlines that fly commercially around the world to do the deposition of sulfur in the stratosphere as they fly. For example, if engineering allows them to burn sulfur-rich fuel, unrefined kerosene instead of the highly refined stuff, that would do it. That would put enough sulfur in the atmosphere to give you a Pinatubo every couple of years. It's all very well for wealthy urban people to say, but everybody ought to drive a hybrid or something small. But the average person can't suddenly go out and buy a new car. They're lucky to get their old banger going to and from work. There's a lot of impracticality here. It takes an awful long time. And how do you tell the Chinese to set back the aspirations of their people and stop building coal-fired power stations? They build one every 5 days, believe it or not. It's a very impractical suggestion to ask people to cut back on carbon sufficiently to have a big effect on the world in time. This is it. Time is the essence of everything. So I think those notions of amelioration, like sulfur in the stratosphere or sunshades, are worth pursuing because they will buy us time. But there's a big but. Think of them as like if your kidneys fail, you can always go on dialysis. And who would refuse dialysis if death was the alternative? But it's only going to buy you time, that's all. when you ask the question, have we or when did we reach a tipping point in global heating, I think we've passed the point of no return myself, but it's only a speculation. I can't give you firm figures on it. Others think it will be a few years ahead, but whatever way you look at it, it's pretty close. The long-term prognosis for planet Earth is, strangely enough, more clear-cut than the short-term prognosis, because, you see, the sun remorselessly warms up. We know pretty well how it works, and it's got a greenhouse problem, just like the Earth. It burns hydrogen by fusing it together, and the product, the ash, is helium. And as helium accumulates in the sun, just as CO2 accumulates in the Earth's atmosphere, it acts like a greenhouse gas and makes the middle of the sun hotter, so the hydrogen burns faster. It's as simple as that, and the sun is warming up. And as it warms up, life on Earth becomes more and more difficult. And we reckon in 1 billion years, the output of the sun will be putting 2 kilowatts of energy for every square meter of the Earth's surface. And that's more than the system can manage if it's a carbon based life system. And that's the end. However, long before that 1 billion years is reached, shall we say 500 million from now, some catastrophe, like a planetismal impact, will put such a stress on the remaining ancient Gaia, so to speak, that it will crash then and go to its dead state, like Mars or Venus. Everything in this universe is mortal, even stars, even galaxies. They're all mortal. It's part of the name of the game called the second law of thermodynamics. Everything runs down, grows older and dies. And if that seems gloomy, think of it the other way round. If it weren't doing that, you wouldn't have any energy to do anything. We have to adapt. Adaptation is the thing humans have to do, and the thing they most have to remember is to try and preserve civilization. That's our most precious assets, and we're a huge benefit to the world that way. We tend to think of ourselves as some sort of plague or destructive agency. We are, but at the same time, we are something wonderful. After all those 3.5 billion years of evolution, the Earth at last has something with intelligence and communication, which is part of it, because we're part of it, we're natural. We shouldn't think of ourselves as separate from the Earth. And through our eyes, the Earth has seen for the very first time from space what an incredibly beautiful planet she is. And that's worthwhile, well worth it.